Shout out from West Virginia. Hope you're doing well. Are you ready to go? I know you are because you love Joke of the Day and cannot wait for the best part of the day. So here we go. Although the invention of the shovel was groundbreaking and the invention of the broom truly swept the nation, it was the invention of the wheel that really got things rolling. Alright, let's roll ourselves into a little bit of math and take a look at order of operations. Order of operations is critically important to your success in an algebra class because not only does order of operations allow us to simplify expressions like you would see right here, and you've seen this kind of stuff before. People post it on Facebook and go, what's the answer? And everybody comes up with different answers. But it also allows us, as we move into the idea of solving equations, allows us to be able to solve equations because we are going to be working backwards. So in other words, when you go to put on your shoes and your socks, you don't put your shoe on and then put your sock on over top of that. That doesn't make any sense at all. You put your sock on and then your shoe. But then when you go to reverse that and take everything off, you take your shoe off first and then you take your sock off next. You're reversing what you did. Keep that in mind as we get into equations because this is why it is so important to understand the correct order of operations. Like I said, even stepping back from the idea of being able to solve equations, just simply being able to solve expressions and get us all to the same right answer. We need to get to the same right answer because there's only one right answer. And so we need a system, an order, in order to get us there to that same right answer. So this is our order of operations called so because order matters tremendously in order to be able to get to that correct right answer. It's the order of the operations because we're looking at the operations that we use in math. Add, subtract, multiply, divide, exponents. All of these operations being able to put them into the correct right order. So how do we remember the correct order? There's a phrase that we use all the time and it's called, please excuse my dear Aunt Sally. She embarrasses me all the time and so I'm constantly needing to make apologies for her, but I love her dearly and I'll keep her. So please excuse my dear Aunt Sally, shortened to PEMDAS. A lot of people have heard of PEMDAS. But if you struggle with PEMDAS, here's another way to remember it. Please excuse my dear Aunt Sally. The P stands for, what does it stand for? Yes, P stands for parentheses. Parentheses. What does the E stand for? Exponents that we've talked about before, taking a base and multiplying it to itself the number of times that you see in the exponent. And the M stands for multiplication. The D stands for division. The A stands for addition. And the S stands for subtraction. I'm going to go ahead and write out subtraction rather than abbreviate it because I don't want it to look like substitution. However, there is something missing in here. A lot of people don't realize that it's missing. A lot of people don't teach this, but it's critically important. What's missing? Yes, the idea that I need to group these up and I need to group these up. And the reason that this is so important is because here in America, we read from left to right. We also do our math from left to right. As you would see in this expression down here, we work from the left to right. So as we're working from left to right, what happens here is we go through and we say, okay, I'm going to take care of all my parentheses. Now, quite frankly, I would prefer that we don't call it PEMDAS. Actually, I would prefer that we call it GEMDAS because you've seen more than just parentheses and grouping symbols. You've seen parentheses, you've seen brackets, you've even seen braces. And so what this would indicate, if it wasn't PEMDAS and it was GEMDAS, it would indicate let's take care of all these grouping symbols. Get them all cleaned out. The way that you would do that is you would say, okay, let's go way deep inside the belly of the whale, and let's peel ourselves out of there. So what we would do if we were working on all these grouping symbols together is we'd go way deep inside, we'd take care of everything that's within this parentheses using all the rest of these order of operations. We'd clear this all out until there was nothing left that we could simplify within that parentheses. When there's nothing left that we can simplify, then the parentheses is gone. Working ourselves out of there, we would do the same thing within these brackets. Using all of these order of operations, we'd take care of everything we could possibly take care of until there's nothing more that we can simplify. And then those brackets would be gone. And then we do the same thing here using all these order of operations, clear up everything we can clear up within that braces until they're gone, and that would take care of all these grouping symbols. So like I said, I would prefer that it was called PEMDAS, but then that kind of messes this up. Other than we would come up with a new sentence, but here we go. Let's just stick with our PEMDAS. Understanding that this really means all grouping symbols. Now after you've cleared out all those grouping symbols, you continue to work on these. Exponents comes next. So you take care of all those exponents, and then here's the catch. Like I said, working from left to right, multiplication and division are a group. It's not that you do all the multiplication and then you do all the division. That's not how it works. You actually work on these together. So as you're going from left to right, whichever you see first, that's what you take care of. So in other words, as I'm going from left to right, if I happen to see division before I see multiplication, which do I do first? Do I come down here and do the multiplication and come back there and do the division? No, not at all. I'm working from left to right, so I'll do that division, and then I will come down here and do that multiplication. Once I've taken care of all the multiplication and division, all of it, then that's done. Now I head to the addition and the subtraction. Again, working on them together as a group. So in other words, as I'm going from left to right, if I happen to see subtraction here and addition down here, do I come down here and do the addition and come back there to the subtraction? No, not at all. I will do this subtraction and then come down here and do this addition and clean all them up until I've combined everything into that one single right answer. So let's take a look at this and let's practice with it. In this example, notice that I've got multiplication and I've got exponents. So as I do my order of operations, it says clear out all those grouping symbols, but I don't have any. Next, move on to those exponents. Well, my exponent says 2 to the third. 2 to the third means 2 times 2 times 2. Well, 2 times 2 is 4. 4 times 2 is 8. So this is going to indicate now 4 times 8, and 4 times 8 is 32. There we go. It is simplified into my one correct answer because I used my order of operations properly. Now, let's take a look at the next one. Notice these two look an awful lot alike, whole lot alike. What's the difference? Yes, this one has that grouping symbol in there. So this one says, okay, order of operations says do the grouping symbols first. I better do that grouping symbol first. So inside the parentheses, it says 4 times 2. Well, 4 times 2 is 8, so this is going to indicate 8 to the third power. Now, 8 to the third power means 8 times 8 is 64. 64 times 8 is going to be 512. Excuse me. Notice there is an enormous difference between 32 and 512. And it has everything to do with this grouping symbol that you see in there. So you need to follow this order of operations to a T correctly to get the one right answer. Excuse me. Now, let's take a look at our next example. Following order of operations going from left to right, I would do my grouping symbols first, but there are no grouping symbols. So I head to my exponents. There are no exponents, so that means multiplication and division as a group. So I do whatever I see first. I see division, I see multiplication. And like we said, that does not mean come down here and do this multiplication, then come back here and do the division. I do whatever I see first, working from left to right. So 14 divided by 7 is 2. As you simplify these expressions, one of the best pieces of advice that I can give you is do only one, maybe 2 operations at a time. But do that one operation, write down everything that's left. Be very organized in what you're doing. The biggest mistake that I see people make is they just really frankly get sloppy. And they will do this. They'll write down that 2, and then they'll be like, okay, well 2 times 2 is 4, and they're just very sloppy. And this is how you make mistakes. So what you need to do is do one operation, write down everything that's left, because this will keep you from making mistakes. Now I've taken care of that division. I'm going to continue on with this multiplication division. I'm not done with that group yet. 2 times 2 is 4. And now 4 minus 3 gives me 1. So there's my one correct answer. Notice that had I not followed this correctly, I would come up with a completely different answer. Watch what happens here. If I would do, say for instance, I know that I do this as a group and I know I need to do that division first. What if I jump down here and grab this multiplication? Because a lot of people would think, well, it's not going to make a difference. It's going to make a huge difference. Watch what happens. So if I do this multiplication, 7 times 2 is 14, and I'm going to write down everything that's left. And now I'm going to do that division because I'm going to do division before I do the subtraction. 14 divided by 14 is 1. Now 1 minus 3 is a negative 2. That is definitely not the same thing. So you can see that the order in which you do things matters tremendously. And like I said, this is a group. Do it together, working from left to right, whichever you see, do first. I saw the division first. I need to do the division before I do that multiplication because you could see when I jumped down and grabbed that multiplication, it got completely messed up. So let's try a few more examples of this just to make sure we get really, really good at it. Okay, remembering PEMDAS. I need to do all my grouping symbols first. I see a parentheses right in here that I need to fix before I do anything else. And remember, I'm going to do one step at a time and write down everything that's left. So I'm going to write down my 8, my plus 3 times 5 squared, minus, I'm going to do that parentheses. 18 minus 8 is 10, and now my parentheses is gone. I'm going to write down everything that's left. Now in PEMDAS, the P is gone, E is next, exponents comes next. So 5 squared means 5 times 5, 5 times 5 is 25. So once again, I'm going to write down everything that's left, doing only one step at a time so that I don't make any mistakes. I've taken care of the E in PEMDAS. Now it's down to that multiplication division as a group working from left to right. So as I go from left to right, I see multiplication here. 3 times 25, well, if I have 3/4, I have 75 cents. So 3 times 25 is 75, doing one step at a time, writing down everything that's left. Notice that I am not done with multiplication division as a group. I have division right here that I need to fix. So 10 divided by 5 is 2, and again I'm going to write down everything that's left. Now I'm down to addition and subtraction, working from left to right, whichever I see first. I do see the addition first, so I'm allowed to do it first. 8 plus 75 is going to be 83, and 83 minus 2 will give me the 81. That is my one correct answer because I did my order of operations correctly. All right, let's try a couple more. Take a look at this one. Lots of grouping symbols in here. Remember, this is why I said I'd prefer to call it PEMDAS. So what I have to do is go way deep inside, peel my way out. So as I go deep inside, I see this 4 plus 8 that I need to take care of first. I'm going to write down everything that's left, and 4 plus 8 is going to be 12. 5 sitting right up against, remember when things sit right up against each other, that indicates multiplication. So this is going to be 5 times whatever I get out of that parentheses. And notice that the parentheses is gone, but I still have this grouping symbol that I need to take care of. So within that grouping symbol, I have subtract, multiply, subtract. According to PEMDAS, multiplication comes before subtraction. So once again, I'm going to be organized. I'm going to write down everything that's left. 5 times 12 is 60. And I'm going to, again, write down everything that's left. Still not done with this grouping symbol because within it I've got a couple of subtractions. So I'm going to work my way from left to right. 20 minus 60 is a negative 40. Still not done with that grouping symbol there. And negative 40 minus 6 is going to be a negative 46. And now 19 plus a negative 46 is going to give me a negative 27. And there is my one single right answer because I followed all my order of operations correctly. All right, let's try another one because we're getting really good at this. We've got the hang of this. So PEMDAS says, PEMDAS is what I prefer. Go way deep inside and work your way out. So way deep inside here, I've got a 3 plus 5, which gives me 8. And way deep inside, whoa, I got a lot happening in this one. I've got exponents and subtraction. But according to those order of operations, I do this exponent before I do the subtraction. So 4 squared, 4 times 4 is 16. But notice that I've not wiped this out because I still have an operation in there. 16 minus 1 is 15. Let me clean that up here. So now this parentheses is gone. Notice that this parentheses is still there, but there's nothing inside that parentheses other than the 8. So this one, frankly, is just going to simply indicate 8 squared. I've got this bracket here that I still need to fix in terms of the PEMDAS, PEMDAS, whatever you want to call it, that grouping symbol that needs to be done first. I'm not done there because I have 2 operations happening, exponents and subtraction. But remember that within that order of operations, exponents comes before that subtraction, and please excuse my dear Aunt Sally. So 8 squared means 8 times 8. 8 times 8 is 64. So now I've got 64 minus 15. And 64 minus 15 is going to be a 49. And now 98 minus 49 is going to give me a 49, yeah. And so I've got the one correct right answer because I followed the correct order of operations. All right, let's try a few more just to make sure we're really good at it. All right, so let's take a look at a couple more examples of using these order of operations. So notice in this one, whoa, a bunch of fractions, and everybody freaks out about the fractions, but remember, we've got this. We're good at fractions. So notice that within this PEMDAS, grouping symbols being the P, I've got parentheses here and brackets here as well. And so remember, that means that I got to go way deep inside and peel my way out. So as I go deep inside, I need to subtract these 2 fractions. Well, recall what it takes to subtract fractions. Yes, I have to have common denominators. So I'm going to look at this and I'm going to say the common denominator for a 2 and a 3, the smallest number they will both go into will be a 6. So what I'm going to do is write down everything else so I don't mess myself up and I don't lose anything. But now I'm going to convert these both to 6 in order to be able to work this out. So 2 times 3 will give me 6, and 1 times that same 3 will give me 3. So 1/2 is the same thing as 3/6. 3 times 2 will give me 6, and 1 times that same 2 will give me 2. So 1/3 is the same thing as 2/6. So if I take my 3/6 and I subtract my 2/6, now that I have the common denominator, I simply work the numerators. 3 minus 2 is 1, that gives me 1/6. And so that takes care of the parentheses. It is now gone. But notice that within the parentheses, I still have a lot going on here because I still have this multiplication and the subtraction before I can get to this multiplication on the outside. Now within this grouping symbol, within the brackets, I have 2 operations. I've got multiplication and subtraction. So according to order of operations, I have to do that multiplication before I do the subtraction. How is it that you multiply fractions? Oh yeah, there's that game symbol. When I multiply fractions, remember I cancel on the diagonals and then I shoot straight across. So I'm going to cancel on these diagonals here. The 3's will cancel out to be 1s. And I'm going to cancel on this diagonal here. 2 goes into 2 once and into 4 twice. Now I'm ready to shoot straight across because nothing cancels here, being that it's a 1 and a 2. Nothing cancels here because it's a 1 and a 1. And when I shoot straight across, I get 1 over 2. So I'm left with a 1/2 minus 1/6. And then I'm going to multiply that by 12. So now in order to subtract, remember, once again, that means common denominators. The smallest number that a 2 and a 6 will go into is a 6. So the good news is the second one is already in 6. I just need to convert that 1/2 into 6. And once again, 2 times 3 will give me 6. 1 times 3 will give me 3. So my 1/2 is the same thing as 3/6. Now 3/6 minus 1/6 will give me 2/6, which technically I should reduce. I should simplify it. But notice that what's going to happen here is I'm going to take that fraction, I'm going to multiply it to that 12 because when things sit up against each other, it indicates multiplication. So when I multiply fractions, here it is again, that gang symbol. I'm going to cancel on those diagonals and then I'm going to shoot straight across. So when I cancel on these diagonals, 6 goes into 6 once and it goes into 12 twice. Now nothing cancels on this diagonal because this is a 12 over 1, so nothing's going to cancel. And so now as I'm ready to shoot straight across, 2 times 2 is 4, 1 times 1 is 1. So basically it's a 4 over 1, which is just a 4. There is my one single right answer because I followed my order of operations correctly. Now let's take a look at this one. Yet again, a whole lot going on here. This looks very, very different because of this bar. Now remember, the bar means division, and so when we think of order of operations, multiplication, division are a group, but this bar also is indicating fraction. I don't want to deal with that division as division. I want to deal with it as fraction. Get this down to a single number on that numerator, a single number on this denominator, and then simplify that fraction. So let's just deal with that numerator and the denominator separately and then deal with simplifying the fraction. So on that numerator, I've got a couple of operations. I've got multiplication and addition. The multiplication comes before that addition. So when I multiply 2 times 7, I get 14. And when I multiply 5 times 3, I get 15. So now I'm down to just this addition on the numerator and the subtraction on that denominator. Working with them as a group, going from left to right. Well, up here, there's only one operation. 14 and 15 is 29. On that denominator, there's only one operation. 30 minus 29 is 1. Now I can simplify that fraction. And 29 over 1 is just a 29. Again, got to that one right answer because I used my order of operations correctly. Wow, lots going on here, but I know you've got this because you know those order of operations. PEMDAS says do those grouping symbols first. Well, I got all kinds of stuff happening in here because I've got the parentheses, I've got the brackets. Go way deep inside, peel your way out. So deep inside with this parentheses, 2 plus 14 gives me 16. I'm only going to do one step at a time so that I don't confuse myself, and I'm going to write down everything that's left so that I don't make mistakes. So now I've gotten rid of that parentheses, and I'm ready to move on to get rid of the rest of the grouping symbol there. Within these brackets, I've got exponents and I've got division. Remember, exponents comes before division in PEMDAS. So I need to do that 4 squared, which means 4 times 4. 4 times 4 is 16. I've got to do that before I do anything else. So within these brackets, I've got 16 divided by 16. And now I'm ready to continue on. Feeling pretty good about this. But I'm not done with the grouping symbols because I need to do that 16 divided by 16, which is just a 1. So what I have now is 20 minus 1. That grouping symbol is gone because I've taken care of everything within it. And now I'm ready to continue on. So I've got subtraction and addition. I've got exponents and subtraction. Exponents comes before the addition and the subtraction. 4 squared, 4 times 4 is 16. So what I have is 20 minus 1 plus 5 over 16 minus 13. Now on that numerator, remember, addition and subtraction are a group. Work from left to right. Whatever you see first, I see subtraction first. So 20 minus 1 is 19. So I have 19 plus 5 and 16 minus 13. Now 19 plus 5 is 24. 16 minus 13 is 3. And now simplify that fraction. 24 divided by 3 is just 8. Ta-da! There it is. And see, I knew you'd get it because you've got those correct order of operations. And notice, like I said before, one operation, maybe 2, but 1 or 2 at a time, and that's it. Write down everything else that you've got left so that you don't lose anything, and just be very systematic, very organized in what you're doing, and you will get it right. Now, let's expand our horizons with these order of operations and take a look at situations where, whoa, what is happening here? We've got a bunch of letters in there. What is going to happen when you have a bunch of letters? Well, notice in these examples it says that I'm going to evaluate each for each of these representations. So what that tells me is when the A is a 1, I can substitute that 1 everywhere I see an A. When the b is a 2, I can substitute the 2 everywhere I see a b, and so on and so forth. So in this first example, in order to evaluate it, I need to make these substitutions, and then I can follow my order of operations correctly. So when I make those substitutions, this x is now a 6, the b is now a 2, the m is a 3, and now I have nothing but numbers, and I can follow my order of operations, which again says PEMDAS, do all those grouping symbols. Even though it means parentheses, it means all grouping symbols. So I'm going to go way deep inside, and I'm going to peel my way out. Deep inside here, 3 plus 1 is 4. I'm only going to do that one operation. I'm going to write down everything else so that I don't make any mistakes. But notice that even though the parentheses is sitting there, this really means 2 times 4. Sitting up against indicates multiplication. So I have multiplication and subtraction within that grouping symbol. I got to clean all that up before I can get rid of these brackets that are here. So order of operations says do this multiplication before I do the subtraction. 2 times 4 is 8. So what I have now is 6 outside, 8 minus 3 inside. And 8 minus 3 is 5. So now it's just 6 up against the 5, and like we said before, up against always indicates multiplication. And 6 times 5 will give me 30. There is my one single correct answer because I use those order of operations correctly. So now when we look at this one, once again, the only way I can get through it is to make these substitutions first. The m is sitting right up against the n, so that indicates multiplication. So it's going to be 3 times 10 to begin with. So 3 times 10 minus 5 sitting up against the y means multiplication. The y is a 0, so 5 times 0. And on that denominator, a is now a 1 and b is now a 2. So now I'm ready to follow correct order of operations. Remembering, yes, this bar means division, but it also indicates fraction. So shave this down to one number on the numerator, one number on the denominator, and then simplify that fraction. So to simplify and shave down this numerator, I've got multiplication here, subtraction here. Multiplication comes before subtraction in PEMDAS. So 3 times 10 is 30. 5 times 0 is 0. And now I've taken care of all that multiplication. So now on that numerator, 30 minus 0 is just 30. 1 plus 2 is just 3. And to simplify that, 30 divided by 3 is just a 10. Ta-da! There is my one single correct answer. I'll put little arrows in here. I try to hesitate to put equal sign because that indicates that I've got an equation there, and I cannot miraculously turn that into an equation. So try to be very careful about that. All right, last one. Make those substitutions, and then you can go from there. So we have 2/3 times 8 parentheses. The x is a 6. The m is a 3. The m again is a 3. They're sitting beside each other. That indicates multiplication. And now I'm ready to roll, following PEMDAS. Remember, lots of grouping symbols. Go way deep inside. Peel your way out. Deep inside right here with that parenthesis, 6 minus 3 is 3. I'm only going to do one step at a time so that I don't make mistakes. Now, this 8 sitting right beside it indicates multiplication, but it's times 3 to the second power. That second power is only being applied to the parentheses, only applied to the 3, not the 8. Just that 3. But I've got a whole lot of other stuff in there that I got to deal with. So now I'm not done with the PEMDAS, the P in PEMDAS, because I've got this grouping symbol I've got to fix. So inside it I've got multiplication, exponents, addition, multiplication. Within PEMDAS, exponents comes next. 3 squared, 3 times 3 is 9. So now it's 2/3 times the 8 times 9 plus 3 times 3. Now within that grouping symbol, multiplication, addition, multiplication, the multiplication comes before addition in PEMDAS. So now I can do a couple of operations at once because they're both multiplication. So I'm going to do 8 times 9 is 72. And then I'm going to do 3 times 3 is 9. I'm not quite done with this grouping symbol. I do need to add 72 and 9, and I'm going to get an 81. But now remember, because this 2/3 is sitting right up against that 81, that indicates multiplication. So I'm going to multiply 81 by this fraction. And remember, when you multiply fractions, bam, there it is, that gang symbol. So what I'm going to do is I'm going to put the 81 over a 1. I'm going to cancel on those diagonals, and then I'm going to shoot straight across. Nothing cancels on this diagonal. On this one, 3 goes into 3 once. 3 goes into 81 27 times. Check up and down to see if anything cancels before you shoot straight across. Nothing cancels here. Nothing cancels here. So when I shoot straight across, 2 times 27 is going to be 54. And then on that denominator, I have 1 times 1, which is just 1. And I don't need to show that 1 in that denominator. There's my 54, my one right answer. And I know that it's right because I followed order of operations correctly. All right. One last thing, we're going to take a look at a word problem, a real world example of where order of operations would be important. Okay, so here we are with an application of order of operations. There are so many applications for order of operations in the real world, lots and lots of uses. This is just one. So in this situation, we have this formula, I equals negative 0.09 n squared plus 53n plus 315. This formula describes the number of inmates in U.S., state, and federal prisons after the year 1980. The I in this formula represents the number of inmates in thousands. The N in this formula represents the number of years after 1980. And so we want to use that formula to find the number of inmates in thousands in the year 2000. Well, in order to do that, first we need to figure out, okay, if we're talking about the year 2000, how far after 1980 is that? Well, if we take 2000 and we subtract 1980, that gives us 20 years. And that's going to be our N, because remember, N represents the number of years after 1980. So to figure out the number of inmates, this I, we need to take this N and we need to plug a 20 in for that in order to be able to calculate it. So I'm going to take my formula and I'm going to plug in a 20 for the N everywhere I see it. So negative 0.09, 20 squared, plus 53 times 20 plus 315. And now I'm going to follow order of operations. So according to order of operations, I've got multiplication sitting here because remember, sitting beside indicates multiplication. So I've got multiplication right here, exponent, addition, multiplication, addition. And according to order of operations, I have to do this exponent first. Well, 20 times 20, 2 times 2 is 4. And then 10 times 10 is 100, so this is going to be 400. 20 times 20 is 400. So what I have now is negative 0.09 times 400 plus 53 times 20 plus 315. So now what I have is multiplication, addition, multiplication, addition. And remember, in PEMDAS, this multiplication is going to come before the addition. So I need to multiply 0.09 times 400 and a negative 0.09 times 400. When I get that multiplication, I will get a negative 36. Go ahead and do this multiplication as well. 53 times 20 is going to be 1,060. And now I'm ready to just do that addition, moving from left to right. So a negative 36 plus 1,060 plus 315 will give me 1,339. Now, we need to be very careful because remember, the I represented the number of inmates, in thousands. Because this does not mean 1,339 inmates. This means 1,339,000 inmates. That's a whole lot more. So we have to be very careful about what that represents. 1,339 inmates, if you think about it, that actually means 1,339,000. So it actually means 1,339,000 inmates. Now, it did tell us to express it in thousands, so this will be our answer, 1,339,000, which is very hard to wrap your brain around. That's a very strange number. This is the way we're supposed to express it because it says find the number of inmates in thousands. So this is how we're supposed to express it. But in order for us to understand what that means, just remember, take this and throw 1,000 behind it, 3 zeros. That will allow us to really comprehend what that number really means. 1,339,000 inmates. So hopefully this gives you an example, or it does give you an example. Hopefully it helps you to understand where order of operations really is helpful in the real world. And like I said, so many other applications than this one. I hope it helps. Have a great day. Okay, so let's take a look at one more example of being able to use order of operations in order to solve a problem. In this application, it says that the formula S equals W minus 10E over M is often used by secretary placement services to find typing speeds. In this formula, the W stands for the number of words that were typed, E stands for the number of errors that were made when typing, M stands for the number of minutes that were typed for the duration, and S is the number of the speed in words per minute. So let's say that Juan took a typing test, and in this typing test, it was a 10-minute typing test, and he typed 420 words with 6 errors. And we want to know, what is his typing speed? Well, we need to take this information, we need to plug it into the formula, and then follow order of operations in order to solve that. So we know that it was a 10-minute typing test, and remember, M is the number of minutes that were typed. So 10 is going to go down here for this N. Now, we said that he typed 420 total words, and remember, W was the number of words that were typed. So 420 will go right here where this W is. And then we found that he made 6 errors. And recall that E was the number of errors that were made. Now, it's 10 times, because remember, when things sit beside each other, it indicates multiplication. So 10 times the E would be 10 times 6. And that will give us the S, which again, S is going to be the speed in words per minute, and that's what we wanted to find was his speed. So now all we have to do here is follow order of operations. We have a subtraction and a multiplication. Yes, the bar means division, but this bar also indicates fraction. We want to simplify the fraction once we have a single number in the numerator and a single number in the denominator. So let's simplify the numerator of the fraction. Subtraction and multiplication, according to order of operations, the multiplication comes first. So 10 times 6 is 60, so that means we now have 420 minus 60, and now we can do that subtraction. And 420 minus 60 will give us 360, and now we're going to simplify that fraction. And 360 divided by 10 is going to be 36. And remember, this is going to be 36 words per minute, and that is Juan's speed. All right, so great application for being able to use order of operations to solve situations. I sure hope it helps. Have a great day.